So basically today we are going to start the new chapter, fourth chapter of chemistry, that is carbon and its compound. So everyone knows that carbon has a symbol, that is, and it is also known that its atomic number that is denoted by Z equals to 6, and its mass number, or you can say atomic mass, its mass number is equal to 12. First of all, I would like to tell you about the representation of an element. Representation of an element. So basically, how we are going to represent an element? If element is X, Z is here and A is here. Or we can write Z here and A. What does this X stand for? So where X is any element, X is any element from periodic table. Z is atomic number, first of all, atomic number, and A is mass number. A is mass number. So carbon can be symbolized as carbon 6 and 12. We are talking about this carbon, and there are isotopes of carbon. Does anyone know what is isotopes? Manha, Abdullah, Martin.
Yes,
can
sir.
anyone tell me about what is isotopes? So I will discuss about it. What is isotopes? So basically, first we are going to study about carbon and its compound. So what is the atomic number of carbon? That is Z, 6. And what is the mass number of carbon? That is 12. And representation of element, atomic number is written down subscript and up subscript mass number. So in this way, I can represent carbon like this. Please write this. And let me know when you are done with this. Okay, Arshia. Thank you for telling me this. So we just started the new chapter, carbon and its compound, and I'm going to tell you about the carbon, and we need to study about its compound. So first of all, we started from very basic, that is carbon, and its atomic number is 6 and mass number 12, and how we are going to represent any element. This is the way we represent elements. So we can represent carbon like this. So please write it. The compound of carbon is very useful in our day-to-day life. Please let me know when you are finished with this.
Done, sir.
Very good, Mana. Abdullah, Amna, and Arshia. Please let me know. Can I change the slide? Okay. Now see. So first of all, I am going to talk about some terms, important terms. And here I will introduce only two terms, that is isotopes and isomers. Isotopes and isomers. So what is isotopes? So basically element having same, or we can write elements having same atomic number, but different mass number is called isotopes. For an example, C612, C613, C640. So this is the isotopes of carbon. You can see the atomic number are same, but the mass number are different. That's why it is isotopes. Again, we can take example 0808, in which this is 16 and this is 17. So again, you can look at this same atomic number, different mass number. This is isotopes. Also, we can take example of hydrogen's isotopes H11, H11, H12, and H13. So this is, you can see atomic number of hydrogen is 1, but different mass number. That means it is isotopes of hydrogen. So this is known as basically protium. If you are going to talk in terms of isotopes, this is deuterium, and deuterium has a symbol D. And this third hydrogen is tritium, and it has a symbol that is T. So this is basically, we just talk about isotopes, same atomic number, different mass number. Is that clear, Mana?
Yes, sir.
Okay, please write. Then we are going to talk about isobars.
So then scroll up.
Scroll up. Okay, Martin. Will this be okay?
Yeah, okay, sir.
Please let me know when to slide down if you're done with this. When you are done with this.
Completed, sir.
Yeah, done, sir.
You are also done with this, right? Then we are going to talk about
Yes.
isobar. Now see, isobars. So elements having same same mass number, elements having same mass number, but different atomic number. Atomic number is called as. For an example, argon has an atomic number 18 and its mass number is 40. In the same way, calcium has an atomic number 20 and its mass is 40. So the elements which have same mass number but different atomic number, that type of elements has a relationship that is called isobar. Is that clear, everyone?
Yes, sir.
Is right. Please let me know when you are done with this, Manha, Arshia, Martin, Abdullah. Amna. Let me know when you are done with this.
Done, sir.
Everyone done with this? In the previous class,
Yes, sir.
very good. I'm going to give you a question on the basis of previous class. Write the electronic configuration of following. Electronic configuration of following. So first of all, I'm going to give you sodium. Then I'm going to give you magnesium. Then I'm going to give you carbon. Then nitrogen. Then oxygen. Then and then aluminum, sorry, neon. Does everyone knows about the electronic configuration and atomic number? For writing electronic configuration, you will be in need of atomic number. So I think you have remembered from 1 to 20, right? Or should I tell you what is the atomic number? So for your hints, I'm going to write the atomic number here. It's 6, it's 7, it's 8, it's 9, it's 10. Please let me know when you are done with this. Mana, can everyone do this?
Yes, sir.
Okay, please do it. I'm waiting. And if you have any doubt, please ask. So what is the electronic configuration of the first one? You can see its electronic configuration will be basically it has atomic number 11. That means 11 electron will be there. So 2 in the K shell, 2 electron will go, and then 8, and then 1. So K, L, and this is M. In the same way, if you are going to do the electronic configuration 2 comma 8 comma 2, in the same way, if you are going to do the electronic configuration, it will be 2 comma 4. This will be 2 comma 5, because whatever is the atomic number, that will be equal to the number of electron. And what we do in electronic configuration, we distribute electrons in the shell. So this is K, this is L. So this will have electronic configuration 2 comma 6. This will have electronic configuration 2 comma N. This will have electronic configuration 2 comma 8. Is this clear to everyone? Please do respond.
Yes.
Manha. Okay. So can anyone tell me, out of this 10, which element is most stable? Can you predict? Can you tell me which element is most stable?
So Florence 27.
Oh, sorry, it's 27. Thank you, Martin. It was my mistake. So can anyone tell me which one will be the most stable out of these 10?
Neon.
Neon. Why neon is more stable, most stable? Because its both shell is completely filled. Its both shell is completely filled. Right now, you have to remember one thing is that when shells are completely filled, that element will be most stable. In order to get stabilized, any element wants to wants itself to be completely filled. So you can see that this sodium, in order to stabilize itself, what will it do? Either it will gain 7 more electron to make it 8, or either it will lose 1 electron to get stabilized. Yes or no? Please do respond. Yes. So what it will do, Martin? It will lose 1 electron, or it will gain 7 electrons.
Lose one electron.
It will lose 1 electron, because it is easy to lose 1 electron instead of gaining 7 electrons. In the same way, this element, in order to get a stability, it will lose 2 electron instead of gaining 6 electron, because gaining 6 electron is quite tougher than losing 2 electrons. In the same way, this can also gain 3 electrons to stabilize itself. Are you getting my point? Here you can see it will lose, it will lose. Here it will gain, because in order to get stabilized, either it can gain 3 electrons or lose 5 electrons. So it will be easy for nitrogen to gain 3 electrons. Are you getting my point? In the same way, this case, to stabilize itself, either it can lose 6 electron, or gain 2 electrons. So it will be easy for oxygen to gain 2 electrons. That's why it will gain. It will also gain 1 electron. Now you can see neon. Neon is already completely filled. So neither it will gain nor it will lose, because it is completely filled and it is stable. Are you getting my point, Martin and everyone?
Yes, sir.
So please write it. Then I will talk about, I didn't talk about this carbon. I didn't talk about this carbon. I will talk about it. First of all, you are going to write it and let me know when you are done with this. Let me know when you are done with this. Everyone done with this?
Yes, sir.
Okay. So now see, this carbon has an electronic configuration of 2, 4. That means either it will lose 4 electron or either it will lose 4 electron to get stabilized. But what it will do? Will it lose or gain? So I'm going to write a topic that is bonding in carbon. So bonding in carbon is basically covalent bond. We have studied about ionic compound or ionic bond in metals and non-metals. Now in this chapter we will deal with covalent bond, and the compound in which covalent bond is present, that compound is known as covalent compound. That compound is known as covalent compound. Now see, I'm going to write 2 points, which is very easy. In order to stabilize itself, either it will gain or either it will lose. So first of all, I'm going to write a point and then I will explain. It could gain 4 electrons, and if it will gain 4 electron, that means C4 minus. When an electron is gained by any element, there will be negative charge, and the negative charge will be equal to the number of electrons gained. That means it gained 4 electrons. That means basically C4 minus anion. But it is very difficult. I'm going to write it, then I will explain. But it would be difficult for the nucleus with 6 protons to hold on to 10 electrons. 10 electrons. Now the next point is it can also lose, so it could lose 4 electrons, forming C plus cation. But it would require, but it would require carbon. Wait a minute. It would,
Large amount of energy.
yes, it would require large amount of energy. Large amount of. I will explain all these points. It's very easy to understand. To remove 4 electrons. So first of all, write this and answer some of my questions. Shravana, did you just join?
Yeah.
So you just joined or you joined a little early? Let me know when you are done with this. Please write it and then let me know.
Done, sir.
Very good. Everyone done with this?
No, no,
Yes,
sir.
sir.
Martin, did you say no?
Yeah, I didn't, sir.
Okay. Please write it. Take your time. No problem at all. Martin, are you done with this?
Yes, sir.
Okay. Before explaining this, let me know. Calculate. I'm going to give you some questions regarding this to explain. It will be very easy. Calculate A, atomic number, that is Z. B, mass number, that is A. C, number of proton. D, number of electron. If you don't know how to calculate, please let me know. And E, number of neutrons. In Al plus 3, and here it is written 13, and here it is written 27. Let me know if you don't know how to solve it. By the way, you can solve it if you have studied class 9 very well, or if you don't know, please let me. Martin, are you solving it? Is everyone able to solve it?
Yeah, I'm doing, sir.
Okay, please do it. Is everyone solving?
Yeah, yes, sir.
Okay, Hamna, Manha, Suvana, Arshia.
Done, sir.
Very good. Are you done with this? So see, it's very simple that this is our atomic number. So the first answer, atomic number will be equal to 13. B is mass number A. So I already told you this is A, mass number, that means 27. Now number of proton. When we talk about number of proton, proton is always equal to the number, atomic number. So proton will also equal to 13. Now when we are talking about electron, you can see number of electron plus 3. What does this means? That means basically it loses electrons. How many? 3 electrons. So initially it has 13 electrons, but it loses 3 electrons. That's why the number of electron will be 10. Now number of proton. Now there is a formula. Mass number minus Z will be equal to number of neutron. So neutron is equal to mass number minus atomic number. Mass number minus atomic number. Now you can see what is the mass number? 27. Just subtract 13 atomic number. So number of neutron will be 14. Is this correct, Mana?
Yes, sir.
Very good. Can we move to the next part?
Yes, sir.
Okay. If there is any doubt to any students, please let me know. Martin, are you done with this?
Yes, sir.
Okay. Now I'm going to give you another part of this. Calculate. The first is again atomic number. The second is mass number. The third is number of proton.
Yes, sir. One thing.
D is number of electron. E, this is P, and E is number of neutron. And we need to do it in first, for first S1632 minus 2, and the second C612 minus 4, and the third one C612 plus 4. Please do it separately.
Minus product from one thing.
It's very easy. Everyone done with the first one?
Yes, sir.
So I'm going to write the answer. Please match it.
Okay.
So if we are talking about this, atomic number Z will be equal to 16, mass number will be equal to 32, number of proton will be equal to this 16. When you are going to talk about electron, you know that 16 electrons should be there, but minus 2, that means it gained 2 electrons, so it will be 18 electrons. Negative sign, that means it gains electron. And when you are going to talk about neutron, it will be A minus Z, 32 minus 16, that will be equal to 16. Again, if you are going to talk about this, Z will be 6, A will be 12. Number of proton is always equal to atomic number. Number of electron, you can see initially it was 6, but here it is minus 1. That means it gained 4 electrons. So the electron will be 10. And then number of neutron will be equal to A minus Z. That means 12 minus 6. That will be equal to 6. Now, when you are going to talk about this, Z will be equal to 6. A will be equal to the 12. Number of proton is always equal to atomic number. Number of electron. So plus 4, that means initially it was 6. Plus 4, that means it loses 4 electrons. So 6 minus 4, that will be equal to 2 electrons. And also number of neutron is equal to A minus Z. So it will be 12 minus 6. That will be equal to 6. Is that clear to everyone?
Yes, sir.
Yes, sir.
Correct. All are correct, or you did mistake in some of them?
Sir, all correct.
Very good. Very good. So this is how we are going to write the number of electron, proton, atomic number, and mass number, and also number of neutrons. Let me know when you are done with this.
Yes, sir.
Plus 4 or 4 plus. Can I slide it up? Martin, Manha, Amna, Abdullah.
Yes, sir.
Okay. So see what I wrote here. It's very important to note that bonding in carbon is covalent. Why? Why it doesn't lose or gain electron and make ionic bond? So it is very simple to understand that when carbon will when carbon will gain 4 electron in order to stabilize itself, because it has a configuration 2, 4. So either to complete its shell, either it will gain 4 electron or lose 4 electron. What happens when it will gain 4 electrons? Carbon will have negative charge -4. So basically you can think like this is the nucleus, this is the first cell in which 2 electrons are present, and this is the last cell. Initially there was only 4 electrons, but after gaining 4 more electrons, there will be 8 electrons in the outermost shell, and there will be repulsion between the electrons. There will be repulsion between the electrons, because electrons negatively charged, you know that same charges repel each other and opposite charges attract each other. So you can see initially it was 4 electrons, and finally when it gains 4 electrons, it is 8 electrons. So there will be a high repulsion between electrons, and also since outermost shells electrons are increased, or you can see total electrons increased. You can see proton is only 6, that means plus 6, and electrons are -10. So electron will continuously withdraw or attract proton, that will destabilizes it. That's why it does not, or it would not, or it will not gain 4 electrons. Now come to the next point, which is also very important. In order to stabilize, it can lose 4 electrons. It can lose 4 electrons. But when it will lose 4 electrons, that means you are going to remove electron from carbon. So see what happens. So initially 2 electrons are here and 4 electrons are here. Now if you know that this nucleus will have 6 electrons, and total electrons in the atom is 6 initially. Now, if you want to take this electron from this carbon atom, you will have to spend some energy. You will have to give energy to excite this electron and remove it from carbon. You can do the first one easily. But when you are going to remove the second electron, since now the electron will be 5 and proton will be 6. Now proton positive power increases. That means the rest 5 electrons will be attracted towards nucleus more than the previous one. More than the previous one. Okay. More than the previous one. So you have to again apply the energy or give energy more than the previous one in previous energy. Then this electron will also eliminate or emit, or you can take it. When you are going to remove the third electron, you have to give a lot of energy. A lot of energy are required. That's why we do not take all the 4 electrons, or we cannot take all the 4 electrons from carbon, because we will be in need of too much or a very large amount of energy. So carbon will neither gain 4 electrons and will neither and nor lose 4 electrons. Is that clear to everyone? So what does carbon do in order to stabilize itself? It shares, and when a bond is basically when a bond is formed by sharing of electron, that is called covalent bond, and the compound is known as covalent compound. Is that clear? Shobhana, Manha, Martin,
Yes, sir.
Abdullah.
Yes, sir.
So can we move to the next part?
Yes, sir.
Okay. So I'm going to write a point. Since carbon neither lose its 4 electrons on and not gain 4 electrons in order to achieve noble gas configuration. What is noble gas configuration? The 18th group: helium, neon, argon, krypton, xenon, radon, or stability. Overcome this problem, carbon shares its valence electron. Carbon shares its valence electron with other atoms of carbon and element with other atoms of carbon or with atoms of other elements. So since we know that it cannot lose or gain, so what it does to overcome this problem, it shares electron with other carbons or with other elements to form compound or to stabilize itself. Please write it and let me know. And always remember that when it shares electron, that is valence electron. That means the electron present in outermost cell. Let me know when you are done with this. Let me know when you are done with this.
Yeah, done, sir.
Everyone done with this?
No, no.
Okay, please write it.
I have done, sir.
Very good. Martin, are you done with this?
Yes, sir.
Okay. Now see, before starting this sharing of electron, I would like to introduce a term, electron dot structure. Electron dot structure. What is electron dot structure? So I will just define in a single sentence. Representation of an element only with their valence electron. Only valence electrons, or we can write electrons in outermost shell. So whatever is the number of electrons left or present in outermost shell, we will just represent that like sodium, if sodium is there. So what will be the electron dot structure of this? Na dot, because it has only one electron in the outermost shell. If you have carbon, that means 4 electrons in the outermost shell. In the same way, if you have aluminum, if you have nitrogen, that means basically 5 electrons in the outermost. So whatever is the number of electron present in the last shell or outermost shell or the valence, we just need to represent the valence electron. That is called electron dot structure. Is that clear to everyone?
Yes,
Yeah.
sir.
Please write it. After writing, you may leave the meeting. Thank you so much. In the next class, we will learn how to draw the electron dot structure of a covalent compound. And we will also define covalent compound as well as covalent bond. It's a very interesting and easy chapter. And most importantly, very important for your exams.
Yeah, okay, I have done, sir.
Okay, thank you so much.
Thank you, sir.
Thank you, everyone.